Hi, welcome again. After going through the basic data types in the previous episode, this time we'll start working with classes and modules. Of course, being an object-oriented language, Crystal allows you to define classes through the class keyword. Instance members are prefixed with an @, and the constructor is defined as a special initialize method. We also have a shorthand syntax for directly assigning an argument to an instance variable in the constructor. Notice that Crystal's compiler requires us to specify the types of all members of a class. If we remove the type declaration, we'll get an error. Nevertheless, the compiler is smart enough to infer the type of the instance variable if we declare its type in the constructor argument. After declaring our class, we can initialize instances of it by calling new, just like in Ruby. And, of course, we can invoke methods on it. Instance variables cannot be accessed outside of the class by default, so let's create a getter method for that. Now, if we add another instance variable and want to define a getter, the resulting code becomes pretty similar to the previous one. In a dynamic language, we could use metaprogramming for generating these getters on the fly, but we're in a compiled language. So Crystal's answer to this problem is macros, which are evaluated in compile time. Macros expressions in Crystal use the following syntax. Inside a macro, we can use only a reduced subset of expressions, such as conditionals and simple iterations. For instance, we can iterate over an array and declare the getters. Here, we use double braces for outputting a macro variable, and use the id method to output the variable as text, and not as a quoted string. Alternatively, we could declare a macro named getter that can be invoked once for each field. Actually, since getter is such a common use case, it is included in Crystal's standard library, as well as setter and property, which generates both a getter and a setter. Okay, let's move on to the next thing. Crystal, like Ruby, has support for modules. Modules have a set of methods and can be included in a class as a means to insert shared functionality. Let's change our greeter class into a reusable module, which adds the greet method. We will assume that there is a name method where we are including the module that provides the name of the greetie. Let's create an assistant class with the greeting functionality. Note that Crystal in compile time will detect that the name method is not defined by the assistant class. We can actually enforce that method to be present by declaring it as abstract in the module, so we get a clearer error if we forget to implement it. Now let's define name in assistant. It's a good time to point out that, in Crystal, you can reopen a class to add methods to it. Modules can also be used as a namespace to provide standalone methods, which are declared by prepending self before the method name. Know that class methods can be defined using the same syntax. To close this chapter, we'll point out that Crystal also supports class inheritance, using a similar syntax to Ruby's, including the concepts of public, protected, and private visibility. It also includes the concept of abstract classes with abstract methods that must be defined by children, exactly like the abstract methods in modules we've just seen. Crystal also has support for generics, which you will find across the standard library container classes such as array and hash, or you can easily define yourself. Between this episode and the previous one, we have covered most of the language basics. However, we strongly recommend that you take a moment and head on to the Crystal docs to review any concept you'd like to understand in more detail or grasp others that we have glossed over, such as enums or closures. In the next episode, we'll be building some Crystal projects showcasing database access and setting up a simple HTTP server. Happy crystalling!